Right, so we are going to be looking at this video at finance, and we're looking at interest specifically for this one. We'll have other videos coming about the different topics that we're looking at. All of these are linked to what you could be looking at as part of the applications of maths course, rather than just the plain maths course. So, we're going to look at our learning intentions and success criteria, so what we're going to do as part of this, but first we've got a link to what we've learned about previously. So the previous learning that we've done that we're going to be using here are percentages, decimals and powers. So our learning intention, so by the end of this video, if we get all the way through it, you should be able to understand the concept of interest and what it is, know the differences between simple interest and compound interest, and have an understanding of APR. So as all of these things, the things that you need to be able to do with those concepts is you need to be able to calculate simple interest. Most of you should be able to calculate compound interest as well, and some of us will be able to do APR. Right, so first things first is, what is interest? So there's two options for interest. It's either the cost of borrowing money, or it's the profit you get when you deposit money into a savings account. So interest is calculated as a percentage of the loan or savings amount, and if you have a loan, it's paid to the lender in that case, or is paid to the depositor in the case of a savings account. So a savings account is where you're putting money into the bank, and you are, in that case, the depositor, or whoever put the money in is the depositor, and they get the interest. Or if you've borrowed money, then you have to pay your interest to the person you've borrowed it from. So, simple interest. First off, so simple interest is also called flat rate interest. It's calculated as a percentage of the deposit or loan's initial balance. So it's just how much money you're borrowing at the start, or how much money you've put in at the start, and that's what your interest is calculated based on. So no matter how long you leave the money or borrow the money for, the interest is always calculated from that first amount that you put into the bank or that you borrowed. So how do we actually calculate simple interest? So to calculate simple interest, we've got two steps. Our first step is we find the given percentage of the original amount, and we're going to multiply the percentage by the number of years or months given in the question, depending on what it's talking about. So it might be that your simple interest is a percentage per month, or it could be a percentage per year, and that's what you're going to be working from. So here we have an example. So we've got Kay deposited £3,500 into her savings account, which uses simple interest. If she leaves her money for 3 years, assuming she doesn't remove anything, so this is one of the things with simple interest and compound interest as well, is we're going to be looking at people just leaving their money in their account and not touching it, not taking any out, not putting any more in, just putting the money in, leaving it for a number of years or months. So she leaves her money for 3 years. How much interest would she receive at 4.7% per year? So step one was to find the given percentage of the original amount. So the first thing we need to do is find 4.7% of 3,500. So to change a percentage to a decimal, which is what we're going to be doing here, to multiply by to find our amount. So we change the 4.7 as a percentage to a decimal by dividing it by 100. Most of these would be calculator questions, so you could use your calculator to do your divide by 100. However, we should all know how to change percentages into decimals, and that's something you will need to look over if that's something you're not strong with at this point. Other thing, of means multiply. So because we're being asked to find 4.7% of something, that means we're having to do a multiply calculation. So we do 0.047 times 3,500, and we get that is £164.50. So that's how much interest we get for 1 year. Because it's simple interest, our total interest becomes that amount times 3. So we times it by 3, and we get the total interest that Kay would get would be £493.50. Right, so One of the other things we can do with simple interest is using it to calculate loan repayments. So that's what we're going to be doing on this slide. So to calculate a loan repayment using simple interest, we have 4 steps. So we had 2 steps just to calculate our interest and 4 steps if we're using it to calculate a loan repayment. So to calculate the loan repayments using simple interest, what we do, we find the percentage of the original amount, same as we did in the last step. Step 2 is the same as well. We multiply by the number of years or months given in the question. Step 3, we're going to have to add that interest to the original value, and then we're going to divide the total loan amount by the number of repayments you have to make. So let's follow that through and see how those steps work in our example. So our example is Blaine borrows £4,000 from the bank. He is charged a simple interest of 5.9% per year. If he takes the loan over 4 years, how much will he need to pay each month? So first things first, we need to find the percentage of the original amount. So we're finding 5.9% of £4,000. So again, change the percentage to the decimal. Of means times, and then we have £236 a year. Because it's 4 years for the loan, we have to times it by 4, step 2. So we get total interest is £944. So now we need to find out how much total Blaine would have to pay back over those 4 years. So we're going to add the interest to the original value. So total of all repayments is that 4,000 plus the 944. So total amount that Blaine would have to repay is 4,944. And now we need to divide that total by how many repayments. So it's 4 years, and if we're paying every month, that's 4 lots of 12, because there's 12 months in a year. So we're going to have to do our monthly repayment is our 4,944 divided by 48, which gives us £103 per month for his loan repayments. So that is it, I think, for simple interest, and so now we need to talk about compound interest. So compound interest, what is compound interest? So it's different. So compound interest adds interest at a fixed interval based on the current balance, not the original balance, and it's often called interest on interest. With compound interest, the next interest payment is calculated using the original value and the interest you've already received. So it's not just from the original value, it's the original value plus your extra interest. So what happens is we're about to show a graph here. The bottom line, the blue one, is simple interest. What happens every month, it's just the same amount adding on. But with compound interest, as you go, it becomes more and more and more that you're going to owe if you leave it for longer. Or if it's to do with a savings account, what happens is you will get more and more and more money the longer you leave it for. So the relationship for simple interest, as you can see, is a straight line, but for compound interest we get this curve going up the way. So how do we calculate compound interest? So 4 steps for compound interest. So first step, we find the multiplier, so that's our decimal, by adding your interest percentage to 100%. We change it into its equivalent decimal by dividing by 100. Step 3, we use the formula that's just below to find the total amount. And so the total amount is your multiplier, so that decimal we're going to get, to the power of the number of years, times by your original value. And then if they ask, you can subtract your original value to find what the interest is. Because quite often it'll just say what's the final value, not what interest do you get. But sometimes it will ask about the interest, so you need to make sure you're doing that last step if the question asks for it. So here we go, we've got an example. So what interest would I receive using compound interest if I put £2,700 into a savings account with an annual interest rate of 3.8% for 5 years? Again, this is assuming we don't put any extra money in, we don't take any money out, we just leave it as it is. So our multiplier that we need to find, so we've got 100% plus the 3.8. So we get 103.8%, which we divide by 100 to change into its decimal, that's step 2. So we get 1.038. So now we need to use that formula that we've got there in step 3. So our total amount is our multiplier, so that 1.038 to the power of the number of years, which is 5, times by the original value of what we've put in, which is £2,700. So when we do that into our calculator, we get £3,253, 0.497907. But that doesn't make any sense because with money, we only ever have 2 decimal places, so we need to round. So in this case, 0.497 rounds to 50. With the 7 after the 9, that's asking, is this closer to 49 or 50? And 40 and 7, the 7 after means it's closer to 50 than it is to 49. So, last step, because we've asked for it, what is the interest? So we do our £3,253.50, taking away £2,700 to give us the interest, which is £553.50, which isn't bad. Right. So that is compound interest and how compound interest works. The other thing is this method is the same that we can use for finding final values for appreciation and depreciation. So you should have done appreciation and depreciation at some point before now. You may have done compound interest as well, but this is just a wee reminder of how it works. But that the method of the total equals the multiplier to the power of years times your original. That works for that as well as compound interest. So let's talk about APR. So what is APR? So APR stands for annual percentage rate. So it represents the equivalent percentage interest received in a year when the interest is calculated each month. So quite often you get interest added to something on a monthly basis, but your APR is what happens when it's an equivalent to what happens when you've got it over the full year. So you might get 1.2% per month, but you want to know what that would be over the course of a full year. So a nominal APR is the simple interest rate for a year, and an effective APR takes into account the compound interest rate. So what we're going to be looking at is effective APR rather than nominal APR. Nominal APR, you can just add things together. It's quite straightforward. But effective APR is the one that works like compound interest, so that's what we're going to be looking at. So how do we calculate an effective APR? So to calculate the effective APR, what we have to do, 3 steps. 1, we have to calculate the multiplier by adding your monthly interest rate to 100% and dividing to change into a decimal. So same as we did when we were doing our compound one. Compound interest, we use the following formula to find the yearly value. So because it's a monthly interest rate, it's our multiplier to the power of 12 because there's 12 months. And then we're going to times it by 100 to change it into a percentage. And then we need to subtract the 100% again at the end to find the APR. So we need to add the 100% in at the start and subtract it at the end as well. So here we go. So what is the effective APR on an account which has a monthly interest rate of 2.3%? So our multipliers, so we've got 100 plus the 2.3, so we get 102.3%. We need to divide that by 100 to change it to a decimal. So we get 1.023. So step 2 now, we're going to put it in as the multiplier, so the 1.023 to the power of 12 times 100. So for a year, that comes out as 131.373%. Or if we round, 131.4%. So if we subtract the 100 again, we get our effective APR, which is 131.4, take away the 100, so 31.4%. So with this as well, we need to be able to work forwards and backwards. So if we know our monthly, we need to work out our effective APR. And now we need to be able to find our monthly interest if we know our effective APR. So again, 3 steps here. So we calculate the monthly interest from the effective APR. So we have to, again, same here, we have to add the 100 on and then take it on at the end. So we need to add the effective APR to 100% and divide to change into a decimal. Very similar steps to what we've been doing up to now. Step 2. When we were calculating our effective APR, we had to do something to the power of 12. So now to go back, we need to take the 12th root. Because powers and roots are the opposites of each other mathematically. So if we did one to go forward when we're working with something, we have to do the other one to go backwards. So we do that 12th root to change it to our monthly value, and then we have to change it into a percentage. And then our last step, again, we have to take away that 100% to find our monthly interest rate. So, effective APR for a credit card is 160%. What is the monthly interest rate? So, we have to add on our 100% to start us off with. So we end up with 260%. So that means at the end of a year, so at the start of the year, if you borrowed £100, by the end of the year, you would owe £260. So here we go. We divide that to change it into a decimal. So by dividing by 100, so we get 2.60. So we now need to take the 12th root of that value and change it into a percentage. So the 12th root of 2.60 gives me 1.08288, which when we change it into a decimal, we get 108.29%. We subtract the 100% again, so we have 8.29% as our monthly interest rate. So with it being only it's 8.29% a month, which doesn't seem like very much. Over the course of a year, with the fact that it's compounded month to month, we end up with much higher rate at the end of the year. So hopefully that's helped you understand interest, and there should be worksheets and things for you to do on each of these topics, which should be spread out over the course of the couple of weeks where you've been given this video to watch. So thanks, and if you've got any questions you can leave comments and someone will get back to you, or you can leave comments on the Google Classroom for your class with anything you need about this one. And that's us for this video.